Okay. Hey there! I am really excited to be part of this DevFest and being part of the awesome GDG Doha community. And today I'm going to talk about how you can build your first voice-driven web application from scratch. So let's get started. Imagine you can speak to your web application. Let's say you don't need to use your keyboard or your mouse. Your application is ready to listen to voice commands and perform actions for you. How cool is that? Just think for a while, what kind of application would you like to build using these features? Please share your idea in the comment sections. You'll have 10 seconds to do it. Are you ready? Again, please share your ideal web application that can respond to voice commands. So we are going to start the counter. 10 seconds are running. Few seconds left. So the time is over. The time has ended, and it is time to introduce myself. My name is Luis Avilés, and I am consider myself as an open source enthusiast. I love all things web, JavaScript, and TypeScript. I usually speak at tech events, meetups, I write some technical articles, and I author some courses about web development using Angular and also TypeScript. I am the founder of Angular Bolivia community and the NG Bolivia conference. I've been recognized as a Google developer expert in web technologies and Angular 2 years ago. And this is the agenda for this talk. We'll start talking about the web APIs, and after that, we'll be talking about web speech API, the speech synthesis. We'll be running a live demo in order to perform some actions over my web application using voice commands. And right after that, we'll be showing some source code about how the application has been implemented. So what are the web APIs? And API stands for Application Programming Interface. And what does that mean? And according to MDN, which is the Mozilla Developer Network, APIs are constructs made available in different programming language. You can use JavaScript, you can use, for example, Python or any other programming language to allow developers to create complex functionality more easily. If that is a little bit confusing for you, let's think in an example to understand it better. Let's suppose you are really you really like taking pictures to post them in social media, right? You just got a new camera and you don't have too much knowledge about how the camera is working internally. You don't know how it was built. The good news is that nowadays you only need to press some buttons to turn on, turn off, take a picture, start recording a video, and perform other operations with your camera. As you may understand, we are talking about a device that has maybe a complex circuit that involves several lenses, involves sensors, power management tools, and other details. The good news is that you don't need to learn all this stuff or manage the circuit itself. That's how an API works, because it provides a way to create complex applications without having to implement the details or have a very good knowledge of the complex part. In modern web development, we usually use a client-side JavaScript. There are a lot of APIs available today. However, most of these APIs are not part of the JavaScript programming language. We can mention two categories for them then. We can talk about the browser APIs and the third-party APIs. So what does that mean? The browser APIs are available into your favorite browser. What I mean is you can use this kind of APIs in Google Chrome, Mozilla Firefox, or any other browser you want. We can manage, for example, the HTTP requests from our web applications using the Fetch Data API. We can manage or processing audio features in the browser through the Web Audio API, and in the same way for video or even drawing graphics in the browser. On the other hand, if we are thinking to create a client-side solutions that allows interacting with device hardware or applications, for example, if you're thinking to build a web application to manage your camera, your microphone, or interact with the native message applications, you can use device APIs within the browser. Or if you're thinking to persist data for long-term storage inside the browser, again, we can use the client-side storage APIs or think about cache API, for example. What about third-party APIs? As you may guess, these kind of APIs are external to the web browsers. And in order to use any of them, most probably we'll need to download a package or import an external module in our application. Some examples for these kind of APIs are the Maps API. We can talk about Google Maps, for example, the GitHub REST APIs in order to create calls and get data about repositories, the GitHub users, and more. If you are thinking to build an application to display the tweets timeline or something like that, you can use Twitter API. If you need to add a payment processing in your web application, again, you can use the PayPal API. In the same way, Telegram has some APIs available that allows you to create a bot or even create a custom Telegram client application by free. And what about Web Speech API? Now we understand a little bit better about what an API is and how we can use them inside our browsers. Well, a Web Speech API, as this image shows, actually generates a speech from text. It generates a speech to text output, and that means it is able to use the speech recognition feature as an input. In technical words, the speech recognition in your web application will be available once you create an object that matches to the speech recognition interface. This speech recognition interface is available into the Web Speech API specification. Time to talk about the Web Speech synthesis. As this image shows, in simple words, we can say that with the help of this API, we can generate text to a speech output. We have an input, a text file, or a set of strings, and the output will be the speaking, right? So your application will be able to speak to you. The speech synthesis will be available via the speech synthesis interface. And again, that is part of this API specification. And once you have this object, the application is ready to read any text you provide and produce different voice types according the configurations you are going to set. We are going to see some examples about how we can do it later in this talk. Now we are ready to see a demo that I have for you. Let's take a look. I'm going to show you a new window here. I'm going to increase the zoom a little bit. And actually, this is not a complex UI. We have some options here on the side nav to see more about the source code and the blog post explaining how this application has been built. And also you can find an option here on the upper right corner with a set of the available options or actions for this application. We can perform different operations using voice commands. For example, we can perform the change theme or perform a change title inside this application. And in order to perform these operations, you'll need to make sure to use either English or Spanish. Then we have a main action button here. So let me put this by default. I'm going to reload this application. And once I press the main action button here, which contains the microphone icon, you're going to see an alert. And that means the application will be trying to listen to you. And before doing that, you'll need to enable the microphone permission inside your browser. If I can decide to close this permission without enabling it, you are going to see an error message like this, because you cannot run the Web Speech API since the microphone permission is not enabled yet. So I'm going to try again, going to press this button, and once I press to the allow option here, we are ready to listen to the user. And this application will be ready to process all the words, what I'm going to say, and of course, perform some operations for you. Let's give it a try. Hi there. This is a short demo about how you can use the Web Speech API. And you can build powerful web applications using voice commands and perform actions inside this application. Let's get started. Perform change theme. Pink. Deep purple. Indigo. Finish change theme. In that way, every time you are talking to your web applications with specific words to perform actions, then your application will be ready to execute some commands for you. And still, the application is able to show you the interim results about what I'm talking in real time. So that was the demo I had prepared for you. And let's continue with the slides to understand how you can build an application like this. And of course, as part of these slides, you'll find a video with another small demo so that you can hear what the application is saying to you right after execute the command. So this application has been implemented using the latest version of the Angular framework. And why you should use the Angular framework. And there are many reasons to use Angular today. We can mention the good tooling support we have, through the Angular CLI because it is easy to create a project using this tool. You only need to run a single command and use some options, for example, to use the strict mode in TypeScript since the version 10 in the framework. And of course, we can think in the set of schematics available in internet to perform actions or changes into your application. For example, I used the ng-add schematic to add the Angular material support in the application I just showed you. And also, if we are concerned about the good performance in our web applications, we can use modules, we can make use of lazy loading features inside the framework. And as I said before, we can use TypeScript for a very good developer experience. We can make sure to use the fast change detection in Angular. You make use of the reactive programming using RxJS. And we can mention also the long-term support we have currently with the different versions in the framework. And also it is right to mention the awesome community all around the world. I'm going to show you now some lines of code to understand how the application has been implemented. The first lines of code is about modeling the errors, the events, and the notifications. Since we are using TypeScript, it is needed to define the appropriate enums, TypeScript enums, or interfaces, classes, and more, in order to make use of the features available inside TypeScript. In this case, I defined the languages supported by the application, and we can find the English and Spanish. And also, I defined a TypeScript enum that defines the string keys that match with the errors we can get from the speech recognition API. And these strings matches currently with the speech recognition specification you can find. I added another TypeScript enum for the events supported by the application using the voice recognition feature. And as you can see, I am ready to start and end these operations. I can also emit an event with the final content about what I was saying to the app. And also I'm able to notify the interim results, as you saw in the demo. An interface to define the notifications is available too. And in this case, this interface is ready to set the appropriate type of the data you are going to emit through the application. And you can configure this notification to send a string, a number, any other custom object. And also we can find the implementation of the Angular service because I used an Angular service to implement or abstract the set of operations or functions we can get from the speech recognition. And as you can see here, I defined an attribute using the interface we mentioned before, and which is the speech recognition. And before starting to use the voice recognition features, it is needed to verify the API is actually implemented and is available in the browser. Once we verify that, in case it supports the web speech API, we can create an object for the voice recognition. If we are working in Google Chrome, we can create an object from the WebKit speech recognition class. And right after that, we are ready to configure this object with the desired behavior. You can configure it in order to be ready to listen or emit the interim results, for example. In the same Angular service, I provided some wrapper functions for the web speech API. In this example, you can find the onStart function, which is going to emit an observable. That means it will create an observable as a wrapper for the on-speech recognition, on the recognition dot onStart function, which is part from the API. And once this event is triggered, the function will be ready to emit and start notification without any data in this case. We just need to notify the voice recognition operation has started, and that's it. In the same way, we can implement an onStop function that is ready to listen the stop action and emit the speech notification with no data. However, it should be needed to listen the interim results and the final results from the web speech API. And for that kind of operation, I defined the onResult function here, which is going to emit again an observable. In this case, is going to set the type of the data as a string, because we are going to emit a series of strings to be displayed into the application. And once we feel we have the final result from the web speech API, the content attribute will have a final string which is going to be displayed in the main screen too. Once we define the Angular service, we'll be ready to use it into the Angular component, right? And in this component, we'll need to inject the Angular service in order to have a new object created from it and ready to be used. And also this implementation from this component defines some attributes as observables, because we'll be using RxJS and a reactive programming approach to implement this application. And that means we are not going to use any subscribe function here. On the other hand, on this Angular component, we'll find an init recognition function, which is going to apply a set of RxJS operators, because remember, we are using observables from the service, and also we defined attributes that are ready to receive those kind of objects. And what is actually an operator in an RxJS context? So for RxJS, operators are functions. And you can find in this example the tap and map functions. And that means we are going to process the input data we're going to have here and emit another observable as a result. On the other hand, the listening attribute gets the result of the creation operator. Because we are using merge, and a creator operation is a function that actually can create a new observable. In this example, the merge function is receiving two parameters. Every parameter is another observable. However, the output of this operation will be a single observable. In that way, we are ready to listen any action there. We can listen the start or end operation from the service. And of course, we are going to process these objects, these notifications, and have a Boolean value as a result, right? If we just started with the web speech API, we are going to emit true, otherwise we'll emit false. In the template side, we can use the async pipe in order to avoid, again, the subscription operation to our observables. In the first case, we are using the async pipe in order to be ready to listen the web speech API action or operations. That means if we are going to receive a true value from this observable, we'll display a sound wave animation and will stop the voice recognition for a click event. It displays the mic, and it is ready to start the device or the service otherwise. On the second case, when the transcript observable emits a new value, it is going to be displayed in real time in our screen. In that way, we don't need to process or perform any other operation or call another function in order to do this action. This is an overview in terms of the application implementation, right? You can have a class diagram here where we can find the web speech component injects the service, and that is going to enable the voice recognition operation. In the same way, we are injecting the web speech, or sorry, the speech synthesis service in order to provide a way to speak from our application. On other hand, I defined the strategy pattern in order to have custom actions for every voice command supported by the application. In this case, I created two strategies. The first one is the strategy to change the theme of the application, and the other one will allows you to change the title. In the same way, you can create other strategies for to implement other actions or operations inside this context. And finally, here are some resources available about this project. For this talk, for sure, you can find the demo project I just showed you. It is available online in the first link. And also, I wrote a blog post a couple of weeks ago about how you can build this kind of applications from scratch and step by step. So don't miss it. Let me know if that article is helpful for you. Of course, the source code is available on GitHub. It is completely open source and ready for you. You can give it a start or fork the project to play it around, and just feel free to send any pull request or add in a new language support or new features for this project. You can find me on Twitter or GitHub as Luis Aviles or any other social network. I hope you enjoyed this talk. Thank you very much.